Hello, I hope everyone is having a good day. I'm Hannah Brackey. I'm the Director of Product Management here at LabKey, and I am happy to talk about sort of the hidden cost of spreadsheets in the lab. I think this is something that we all experience in the lab, and there's a lot of good reasons why. But as a proponent of good sort of data management, data security, compliance, and overall sort of that downstream analytics, I think there's a lot of uh, drivers to consider how we can do things better in the laboratory. Just a few housekeeping things. If you have questions, please put them in the chat. We'll definitely get to them sort of after the presentation. And if we don't get to your question, we'll make sure to follow up in email. This meeting is being recorded, and we will send out the recording to you as well if you're not able to stay for the whole thing, or if you want to share it with some colleagues. Okay, so a couple things about LabKey. We are really a science company, first and foremost. And for over 20 years now, we have been building solutions that have supported researchers in all different types of science. We also have a suite of integrated products that really focus on helping scientists capture work and get work done. We have a very strong ethos in trying to help advance scientific discovery. Myself being a scientist in a past life as well, and also a client of LabKeys, this was really important to me to work with a company that really cared about the research that I was doing. And we also really want to engage in sort of that true partnership with folks and really help people learn best data management practices and utilize those to, again, help advance scientific discovery and the research that they're doing. So spreadsheets and science, it's pretty ubiquitous. And how did we get here? Well, scientists were these early adopters of early spreadsheet tools in the 80s and 90s, something like Microsoft Excel or even Lotus. And we kind of never stopped using them. And the reason behind that was is still kind of they're really easy to use, right? Wherever you go, in a new organization, there's very likely going to be an already offered spreadsheet tool. There's not a big learning curve for these spreadsheets. By now, everybody's using them sort of in their daily life as well as their working life. And there's also no coding or very little coding required. So it doesn't require you to hire a developer or somebody else to utilize these. So it's easy to use, it's easy to get started with. They're also very interdisciplinary. So I'm able to share my Excel file with a coworker in a different division or a collaborator across the world. And it's very likely that they'll be able to open and look at the analysis that I've done or the data that I've collected. They're very shareable in that sense as well. I could even share something with my mom or my parents. And then there's also sort of that increased data handling component. So especially in the 80s and 90s, as we developed instruments that collected more and more data, there was an even greater need to capture this data in some type of spreadsheet or system because we just couldn't possibly handle it on paper or sort of that manual transcription anymore. So really this is why they became so popular after that early adoption, and then how they've maintained their popularity as well into sort of the 21st century here. And so I'm going to start a poll, and I kind of want to see what is sort of the main driver for folks on the call of why you're using spreadsheets. So let me just get that started. And if you don't see your answer here, please just put that in the chat and we can try and call those out specifically. I know for me, we sometimes still use spreadsheets, even at LabKey, a data management company that loves non-spreadsheet solutions. And sometimes, those spreadsheets are useful because we don't have the resources to change to something else, or because we haven't standardized something. And we need kind of that really easy to use and accessible sort of tool to pilot an effort before we get started into something else. And so far, yeah, it looks like lots of folks are really liking spreadsheets, which is definitely totally valid for the reasons that we've talked about. There's also a huge change management component, right? There's a big part of our lab work that doesn't involve sort of managing this data. And so trying to find that balance of getting out of spreadsheets, it can be really, really difficult in organizations and labs in particular. Okay. So hopefully I can talk about why spreadsheets might not be the best for us. And when we talk about kind of a data life cycle, I've created sort of this simplified diagram of what data might look like. So I run an experiment, I put it on an instrument, I get a file from that instrument, and then I need to transfer that to my own computer or to a lab drive or somewhere else where I can make it more accessible. Then I probably move that data into another file to do some QC of it, quality control, or data transformation. I want to start averaging or collating data together to be able to help with my analysis. Sometimes I might even move that data then to another spreadsheet to perform my analysis or another tool. And then ultimately, when I prepare that for sharing or reporting, that might be a PDF image. It might be in more advanced scenarios, maybe like a linked image in something like the Google environment or Microsoft Office. And the reality is at any point in this life cycle, spreadsheets can sort of fail people. And I've certainly experienced many of these, right? Dropping a file that I didn't mean to, transferring only part of the data, doing an incorrect copy paste was sort of my greatest offender when I was in the lab, and certainly what I've heard from others as well. So even in this very simplified process of my data lifecycle, I can start to sort of lose that data integrity or potentially start to misinterpret the data that I've collected out of my experiment and report it incorrectly, which is ultimately, not what we want to do in the scientific realm. So there's a lot of potential costs that can kind of come with this mismanagement of data. And one of those can be bucketed as sort of a time loss component, right? So we all are strapped for time in the lab. We're all trying to figure out ways to save us time and to perform experiments more efficiently. So when I'm wasting time with things like manual data entry, where I'm typing in a bunch of results or copying and pasting, there's sort of that component of time waste. There's a quality control. So when I am kind of at that later stage of my data life cycle, I might realize that there's some data missing or something that looks kind of odd. And so I spend a lot of time going backward in each of these files to understand, did I do something wrong? Or is this really sort of an abnormal result in my experiment that needs to be considered more? Then there's also sort of that data duplication. So without having systems that are centralized or managed well, it's very likely that I run an experiment and then a couple years later, after I've left the lab, another postdoc comes in and tries to run the same experiment because maybe someone remembered that I did that, but we can't find any of the data. And so it's very likely then that you have to sort of duplicate that. There's those poor data integrity challenges that kind of arise with spreadsheets. So when you don't have standardization, there can be kind of that inconsistent collection of the data, and that can really hinder downstream analysis, especially if the data is large. So if I am capturing my tube type as heparin versus EDTA, and sometimes I'm calling heparin HEP, or sometimes I have a lowercase. I have to be able to marry that data later to do sort of the best analysis. There's also the possibility for data corruption. So as an account manager here at LabKey, helping people get out of spreadsheets, this is one of the biggest things that people come to us with is we are outgrowing spreadsheets because we cannot open our Excel file anymore, or we can only open it on this one computer that has more memory because everything else kind of can't handle it. So there's the possibility that that data is corrupted because it's not getting backed up properly. There's no sort of standardization around data recovery processes with these Excel files or spreadsheets. And then there can be that uncertainty of results, right? So if I get that abnormal result towards the end, I start to worry about, did something go wrong in the experiment? Is this a valid abnormal result? Or did I mess something up in kind of that data life cycle that I need to go and search down? There's also collaboration challenges with spreadsheets. So having concurrent access in particular, and I do think that where the technology is going, we have less of that issue with concurrent access, but we certainly aren't registering, who's making changes or things like that. The data can also be really siloed. So if I'm working with a couple of other of my lab techs and I have my analysis on my computer and I need to share that with them, that's something that's sort of, again, that manual effort, and then another piece of that data lifecycle where something can go wrong. And then there can even be sort of a latency problem with collaboration. So with spreadsheets, the data may not always be accessible live or up to date. And so you may be looking at data that's sort of outdated, which then can, cause other problems sort of later down the line as well. And then lastly here, there's really sort of that baseline security and compliance risk. So if you're working in a regulated lab, you already know what I'm talking about, where you do need to have kind of better structures in place to maintain those regulatory standards. But then there's also a lot of security components that that are important to be able to keep your data secure and to also protect the patients potentially that you're working with or other entities, protect the IP of the organization in those types of groups as well. So spreadsheets sort of provide very minimal access control, right? You either have access to that spreadsheet or you don't. And then they also really lack that necessary encryption that in some environments is really important to keep your data secure. And so all of these sort of theoretical costs end up adding up to actual fiscal costs. And what this can mean in some cases is sort of added labor costs. So you are spending a bunch of time doing that manual entry or QC or having to rerun data. That's a real person doing that work and spending time. And so maybe instead of hiring another technician to help out with this, you have a tool to help streamline and make things more efficient. There's the increased operational costs. So if you have those direct research costs, things like reagents, consumables, samples, animals that you're using for these experiments may all sort of add up as you have to rerun things, or if your data integrity gets lost in a way that you're unable to recover that initial data. There can also be sort of delays for non-compliance. So again, if you're in a regulatory lab, you probably know this all too well, that if you aren't in compliance with the regulations that you guys are following, then that can also lead to experimental delays or sort of pauses in protocols while the lab has to get reoriented to follow those regulations. And then there's sort of the elusive like missed opportunity cost, right? So if you're spending a bunch of time dealing with poor data integrity or rerunning experiments from a higher level, you can really miss out on some of that funding opportunity that you may have, publishing a result before somebody else, or really being able to collaborate with folks because you don't have those extra resources or that time to devote to that type of effort. And so hopefully by now, some of us are starting to reconsider, spreadsheets as being the end all be all tool for our scientific advancement, right? And so if I've convinced you that far, I think we can start to talk about when is the right time to move away from these spreadsheets. And there's a few things that people come to us most with when they're trying to get out of spreadsheets that I've sort of documented here. And really, the top one is we're just getting more data, right? Like it's starting to become unscalable, untenable for us to track all of this in these siloed, very fragile spreadsheets. The other kind of pain point that people run into that sort of force them to rethink their spreadsheet use is team growth or increase reason for collaboration. So as I grow my lab from 3 people that are talking every day and are working to maybe 10 or 15 people, I want to be able to start to centralize and have better ways of collaboration for the folks within the lab, but then also potentially me as the PI sort of overseeing what data is being collected. There's also a need for standardization, especially as groups become kind of past a discovery phase, essentially. And it's like, okay, we really want to bear down and perform a ton of these experiments and get the data out. If you can have tools for standardization that sort of help enforce that standardization, then it's a really great way to, move out of spreadsheets and move into a tool that's really better suited for that. Another reason, and that doesn't sort of rely on a change factor necessarily, is if you are seeing a lot of data integrity issues in the lab, if you are recognizing like I'm spending 4 days trying to track down where this result came from, these are reasons to reconsider kind of the use of spreadsheets as a whole. And then, of course, there's those regulatory needs that sometimes sort of force us out of our use of spreadsheets. So that leads me into kind of this slide. So sometimes you want to move out of spreadsheets and sometimes you have to move out of spreadsheets. And there's a lot of regulatory bodies now that are starting to enforce how people are collecting or managing their data within the lab to help improve scientific discovery and validity of results. So one of the things that I think that's been most popular in recent years is mandating data management plans. So the NIH came out with this a couple of years ago, and the NSF has been doing it as well, making sure that labs that they're funding have detailed data management plans to help sort of ensure that data transparency and reproducibility. And the data management plan doesn't necessarily mandate that people aren't using spreadsheets, but it does kind of let us take a step back and consider how are we managing our data and what are the best ways that we could manage this data that could help support that reproducibility and transparency of the work that I'm doing. Other groups are making sure that people have electronic data integrity guidelines kind of in place that help make sure that the electronic systems that people are using are helping with that security of data piece, as well as that it has good auditability. And spreadsheets really have kind of the bare minimum in terms of auditability that doesn't really help us oftentimes understand why something got the way that it did. Other groups are promoting sort of this open access and data sharing, so really sort of supporting that level of collaboration. And again, this doesn't really require people not to use spreadsheets, but certainly it's much easier if you are using the system of choice to help share that data or have it in the same format that those open access groups are set up for. And then lastly, really the adoption of technologies for data traceability. So I think there's both that data integrity lifecycle, but then there's also the sort of human component or element of experimentation that we really want to try and track how we got to this result, again, to sort of serve in that reproducibility piece of science. And so, hopefully this is a little bit self-evident at this point, but thinking about why you really should move away from these spreadsheets. So enhanced data integrity. We've talked about why using spreadsheets can sort of hinder that. Making sure that you're increasing your laboratory efficiency and maximizing kind of those dollars that you're already spending. Having better adherence to those compliance regulations is more of a mandate and less of a request, probably in some cases. And then also having that real-time data access and reporting. So I recall once being in the lab, and I think I just uploaded some data to LabKey, and I had my PI text me and tell me how excited she was about sort of the latest results, right? So to have something that is so easily accessible for everyone in the organization or the collaborators that you're working with can really be a value add in a lot of senses. Improve data security, making sure that you're sort of adhering by organizational standards or regulatory standards, protecting that IP or, again, sort of patient or participant information. Um, uh, uh, Alternatives to spreadsheets will also allow folks to have better integrations with instruments and even other systems. And so removing kind of that siloed component and really having it be part of the holistic data infrastructure. And usually, alternatives to spreadsheets are much more adaptable and scalable than spreadsheets are. And so to have that scalability as you're collecting a lot more data, and that assurance, that it's being properly backed up and things like that, can really help. All of these, as we've mentioned, right, really improve the efficiency and productivity of labs, as well as ultimately reducing costs. So a lot of people associate spreadsheet alternatives for we don't have the budget for this. This is not something that we're willing to do. But ultimately, that cost reduction can sort of save time in the short and ultimately in the long term as well. And so when we talk about alternatives, what are the most popular? We won't bother with sort of paper because I feel like that's bringing us into the wrong direction here. But certainly there is sort of the choice where people can start to think about these custom built or bespoke software systems, or an off-the-shelf software that has sort of out-of-the-box functionality that labs are looking for. And so when we think about in-house systems, I have a lot of opinions to share here. We often have prospects coming to us or clients coming to us that have used a custom system, and this certainly can be a great intermediate. However, A lot of times people are looking to move away from those custom systems for some of the reasons that I'm going to talk about. And one of those is sort of majorly having that technical expertise or resourcing to have that technical expertise. And so oftentimes you need someone or need to hire someone that is a software developer or at least a very skilled um, uh, uh, scientists that sort of learned this as they went, like myself. And they really do need that lab domain knowledge because you want somebody who understands what your challenges are when you're passaging cells or what that looks like, and to use the right language and to make those right connections. It's also very challenging when you're building something on your own to build out systems that really will scale in a way. Access or FileMaker Pro systems are the most common that people start to run into scalability issues over time. There's that long-term sustainability. So I recall in one of my labs, we used a custom system, and the person that we hired to build it ended up taking another job and would still be contracted to update the system for us. And as years went on, it got less and less uh, uh, quick to make requests and to get those fulfilled. And so it's really hard to keep these systems maintained long term when they're not sort of managed by a team of folks. There's usually very little thought to kind of how that user experience and training works as well. So you really then have to rely on the lab to know things and to be able to train each other and to be able to work around, quirks or issues with the system. There is usually very limited sort of maintenance and support. So if there's something to fix or address, questions to ask, that might come at a time delay or never come, kind of depending on where you're at. And then they also really are very hard to adapt over time. So even in ultra standardized labs, you're always trying to work to make your experiments more efficient or to sort of maximize the samples that you're getting. And so to lack that adaptation of your software really means that sort of then you're back to spreadsheets managing those things, and then even kind of across two systems, which can be even harder. There are also a lot of those similar hidden costs, right? So, depending on the folks that are building it, these systems may not provide that added security or regulatory benefit that folks are looking for. There's also the possibility that the time and cost kind of goes way over budget or over the time that sort of was anticipated, just because usually folks doing this don't have a ton of experience in these types of systems, and so the estimates can be off. And then ultimately there's the risk of project failure, right? So if I spend a bunch of time trying to get the system up and running and then it doesn't work, I've now sort of wasted all that time and I'm back at square one. So that hidden time cost it is really a factor here. So now let's think about off-the-shelf options. And where you might start here is, what do you mean by off-the-shelf? And these are really sort of commercial options that people can Google and look for. And there's a lot of different terms I think that are useful to be able to acknowledge and identify and sort of see yourself looking for that can help with that search. So we'll start at sort of the top left over here of a scientific data management system, or an SDMS. And really this is sort of a large platform that can help folks with a lot of customization and a lot of automation around the work that they're doing. This is really can be geared towards larger institutions or groups who are trying to adopt it. Then there is sample management software. So if you're using spreadsheets now to find samples or accession samples, a sample management tool can help do that for you in a much easier way. A LIM system, or a laboratory information management system, is much more of a catch-all of like how do software basically help groups with their experimentation and putting things through sort of standardized workflows. Electronic lab notebook or an ELN, sort of making sure that we're documenting and organizing this information in a centralized, collaborative, shareable way. And then there's also analytics tools that really can help identify trends in your data or things like that. And so there are a lot of benefits, and working at an off-the-shelf software company, I'm going to share these with you, right? It really does mean that you can get started quicker. It is usually in the company's best interest to help you get started, to help with implementation and migration of your data. You also have sort of a lower upfront cost. So instead of paying for a group to build you a bespoke system, you now can just sort of get in at sort of entry level and start using it, and be able to continue that over time. And then there's also a huge emphasis from these companies on the user experience, right? We want it to be easy for folks in the lab to use software. And so we focus very heavily on how those scientists are going to be using it, and how we can make that easier for them. The ongoing support and maintenance as well, as a commercial company, those folks have entire teams. We have entire teams of people that are helping with training and documentation and supporting new users. We've really designed it for the adapting workflows of scientists, and have a huge emphasis on making sure that these systems scale over time, right? So this is our expertise. This is what we're good at. And so how can you benefit from that experience? And then also proven reliability and tested solutions. So basically, a software company is going to have other labs that probably look a lot like you using the system and having tested out kind of before you get on board. So having sort of that cycle of improvement and innovation around the software. Okay, and so I'll stop here for questions, and it looks like a couple of them are coming in. So let me get to that. And I know we're over time a little bit, so I'll be quick, and we'll make sure to sort of follow up on email as well. Um, so any suggestions on how to use existing spreadsheet workflows to inform the selection of non-spreadsheet systems? I think this is a really good question. And what I would really look out for is, what are the types of data that are being tracked in a spreadsheet right now? And we have a lot of expertise on this on our side, where oftentimes we'll say, well, just show us a spreadsheet and we can tell you kind of where this would fit in our infrastructure. But if you're doing this on your own, I'd really sort of recommend looking at what those different data types are and trying to categorize them. So is this participant data or animal data? Is it sample data and the locations of these samples? Is it the analysis? Are we really struggling with getting that data from the instrument to the analytics? And that analysis can vary between people. So interrogating the data for what sort of those core components are, I think can give you some insight of what the solution is that you're looking for. And especially thinking about when you're looking at solutions, let's say it's a LIM solution, looking on vendors' websites for, are they talking about storage management and sample management as part of that LIM solution? Or is it really geared towards assays, which is something that you may or may not be looking for? So looking for that same terminology on websites is also going to really help you identify what might be sort of the best candidates to go for. And then, of course, if you have questions about that, you can always schedule time with us, and I'm happy to talk about it. As I mentioned in the beginning, data management is kind of a passion of mine, so I'm always happy to help labs kind of get started with things. Okay, let's see some other questions. So Another one is how to get sort of organizational buy-in. And this one is really tricky. And there's a lot of change management component to adopting a new system in any situation, right? And so we have a lot of experience with trying to help people convince sort of upper management or even just folks in their lab about the benefits of this software. And oftentimes it really comes from understanding deeply what are the pain points that you guys are trying to solve, and what can our software do to help with those pain points. And we are very transparent and we'll let you know if we don't think that we're the right solution for you. So to have that deep understanding of that buy-in, and then utilizing sort of the vendor as well of their experience in trying to help people with this change management, it is always sort of what I'd recommend. Don't try and do it on your own because you've got better things to do, frankly. What are the best ways to talk more about our lab challenges and possibly help and get advice? So really, if you are looking for help and advice, I think in maybe in the chat or maybe in sort of the follow-up, we're going to have a link to schedule a meeting with me, and I'm happy to talk to you about it. And so that's really where I would start is talking to myself and maybe even some other vendors to be like, what solutions do you have? This is what I'm struggling with. How can you help that? And then about how long do you see it takes customers to get started with your software when migrating from spreadsheets? So I would say overall, it really depends on the amount of data and what system they're going into. But for our sample management product, it's about 4 to 8 weeks, honestly. So it's pretty quick. And oftentimes that variation of timing is due to how many spreadsheets are out there, how clean the data is to begin with, and what that means is like how consistent is it, how easily is it to sort of transfer into the system. But ultimately for us, the implementation is quite quick compared to others. Okay, and it looks like maybe okay, yeah, and perfect. Lance added in, if you want to schedule a meeting, definitely sort of click that link in the chat, and happy to talk to folks about that as well. Okay, any other questions? Well, thank you, everyone. I really appreciate your time today. As I said, I'll just keep repeating it. This is a passion of mine. I love to see sort of labs moving into more manageable systems to help them get their work done. So happy to talk to you more, and please reach out to us if you're interested in talking. Thanks so much.